Hello, class. Today we're going to go ahead and go over 9.7 notes, solving quadratic systems. First, let's go over what a quadratic system is. This is a system that includes one or more equations of conics. Okay, so you have two or more equations in a system, and when it's quadratic, at least one of these is a conic. Let's go ahead and look at the first example. In this example, notice 2x plus y equals -5. That's a line. That's a linear equation. But then the second one is a conic. It's going to be a parabola. So to solve this one, you can choose multiple methods. There's substitution, there's elimination, there's graphing. For this one, I would use substitution. I would replace the y here with what y equals down here. When I do that, I get 2x plus x squared plus 6x plus 7 equals -5. I'm going to combine like terms to get x squared plus 8x plus 7 equals -5. Next, I'm going to go ahead and add 5 to each side to make this equation equal to 0. That gives me x squared plus 8x plus 12 equals 0. Now at this point, you need to determine whether you can factor or if you'll need to do a quadratic formula. In this case, it is factorable. So I'm going to split it up, x and x, 6 and 2, both are going to be pluses. And then I'll use the zero product property to solve. X minus 6 equals 0, x plus 2 equals 0. So x is equal to 6 and x is equal to -2. So we have two possibilities for x. Now remember, in systems, our answers are an ordered pair, which means we also need y values. So we're going to take each of these x values, plug them into one of the original equations one at a time to find the y value that corresponds. So I'm going to use the equation 2x plus y equals -5, and I'm going to replace x with 6 first. So 2 times 6 . Oh, and I made a mistake over here. It should have been plus 6, so that would be a -6. So 2 times -6 plus y equals -5. So -12 plus y equals -5. I'm going to add 12 to both sides. I get y is equal to 7. So what this means is when x is -6, y is 7. That is one of our ordered pairs. For the next one, I'll plug in -2. 2 times -2 plus y equals -5. -4 plus y equals -5. Add 4 to each side. And you get y is equal to -1. So our next ordered pair is -2, -1. So there are two spots where these intersect, which makes sense because if you think about it, it might look something like this, where you have a parabola and then your line goes through it like that. Okay, so then of course you would have 2 points. All right, so in example 2, we're solving the system x squared minus y plus 3 equals 0 and x squared plus y squared equals 9. For this one, I would use elimination and I would get rid of the x squareds. So to do that, I would first multiply one of these equations by -1. It doesn't matter which one. So I'll multiply the top one by -1. That gives me -x squared plus y minus 3 equals 0. And I'm going to put the x squared plus y squared equals 9 here. Now to get these in the same form, I'm going to go ahead and move that 3 over to the other side. So when I do that, it's going to look like equals 3. When I combine these, x squared minus x squared cancels out. There's just that one y squared. There's the one y, and it's going to be equal to 12. I'm going to go ahead and move that 12 over. Y squared plus y minus 12 equals 0. And then I'm going to factor it. So y plus 4 and y minus 3. Using the zero product property, I get y is equal to -4 and y is equal to 3. So we have our y values now. We need to plug these in one at a time to find our x values. I'm going to go ahead and use x squared plus y squared equals 9 to find those x values. So x squared plus, I'm going to plug in -4 first. I get x squared plus 16 equals 9. I'm going to subtract that 16 from each side. So I get x squared equals -7. Now when you go take the square root, to find the square root of a negative number, it'd be imaginary. It's not a real answer. So we're going to go ahead and cross out y equals -4. It's not a solution we'll be using. Let's go ahead and try plugging in 3. So I get x squared plus 3 squared equals 9. X squared plus 9 equals 9. Subtract 9 from each side, and you get x squared equals 0. You square root both sides, which gives you the absolute value of x equals 0, which just means x is 0. So our single point of intersection is 0, 3. Okay. Example 3, solve the system y squared minus x squared equals 16 and y squared plus x squared equals 34. I like this problem because if we use elimination, the x squareds will already cancel out. So I'm going to go ahead and add these together. It gives me 2y squared equals 50. I'm going to go ahead and divide by that 2 to get y squared equals 25. Now I'm going to square root both sides. Remember, the square root of y squared will become the absolute value of y. So what that means is we have two possible answers. Y can be +5 and y can be -5. Now we need to plug these two y values in one at a time to find our x values. I'm going to go ahead and use the formula y squared minus x squared equals 16. I'm going to start with the +5. So +5 squared minus x squared equals 16. 25 minus x squared equals 16. I'm going to go ahead and subtract that 25 from each side. I get -x squared equals -9. Divide by -1. X squared equals +9. Square root both sides to get the absolute value of x equals 3, which means we get x is equal to +3 and x is equal to -3. So what does this mean for our points? What this means is we're going to have two of them. One is when x is 3 and y is +5, and then the other one is when x is -3 and y is +5. So the y value 5 had two possible points from it. We're going to do the same process with -5 for y. So I'm going to replace y with -5. Squared minus x squared equals 16. 25 minus x squared equals 16. Subtract that 25 again. I get -x squared equals -9 again. Divide by -1. X squared equals 9. Square root both sides, you get the absolute value of x equals 3, which means again you get two possible answers. So for the y value, -5, we have 2 points as well. +3, -5, and -3, -5. So this system had 4 answers, which would make sense because you have a hyperbola here and a circle here. So if you think about it, you could potentially cross 1, 2, 3, 4 times. All right, our last example is a word problem. In a science fiction movie script, scientists report that their planet's orbit follows a path modeled by the equation 16x squared plus 4y squared equals 64, and that a comet follows a parabolic path modeled by the equation y equals x squared minus 4. Where can scientists report that the comet might intersect the planet's orbit? So what they gave us here was a system to solve. That system has 16x squared plus 4y squared equals 64, and y equals x squared minus 4. So we're going to have to solve this system. What I would use is substitution because I can replace y with x squared minus 4. When I do that, I will get 16x squared plus 4 times, replace y with x squared minus 4. That is squared equals 64. So 16x squared plus 4 times the x squared minus 4 is times itself. So we are going to have to FOIL that. So I get 16x squared plus 4 times x to the 4th minus 8x squared plus 16. So I just multiplied x squared minus 4 by x squared minus 4. Now I can go ahead and distribute that 4 on the outside. So I get 16x squared plus 4x to the 4th minus 32x squared plus 64 equals 64. Now I want to combine some like terms. I do need to combine 16x squared minus 32x squared. So I get 4x to the 4th minus 16x squared plus 64 equals 64. I'm going to move the 64 over by subtracting it. So I get 4x to the 4th minus 16x squared equals 0. Next, I'm going to go ahead and factor. I'm going to take out a 4 and an x squared. When I do that, I'm left with x squared minus 4. X squared minus 4 can be factored further. So you get 4x squared times x plus 2 times x minus 2 equals 0. And now we can use the zero product property. 4x squared equals 0, x plus 2 equals 0, and x minus 2 equals 0. Divide by 4, x squared equals 0, and square root it. So you get x is equal to 0, x is equal to negative 2, and x is equal to positive 2. Now we need to plug these values in one at a time for x to find our y values. So starting with x equals 0, I get y equals, notice I'm going to use that second equation, 0 squared minus 4. So that is negative 4. That means our point is 0, negative 4. For the next one, y equals negative 2 squared minus 4. So I get 4 minus 4, which is 0. So that point would be negative 2, 0. And for the last one, y equals positive 2 squared minus 4. Still get 4 minus 4, which is 0, which means that last point is 2, 0. So these locations, all three of them are possible spots where the comet might intersect the planet's orbit. And that's it for that problem, as well as for notes today. If you have any questions, be sure to contact your teacher.